Okay, welcome back to the Pat Flynn Show, everyone. We are joined once again by our regular guest, Dr. Jim Madden, and our somewhat regular guest at this point, Dr. Michael Behe. This is probably your third or fourth time on the show. It's always a joy to have you, so thanks for coming back on.
Thanks.
My pleasure. Always a good conversation here.
Yeah, so this one, I think this one will be a little bit different. So, we've covered many different aspects of your work on the podcast before, Dr. Behe, and it's always fascinating. We've had a couple of debates, and I thought they've certainly been interesting and many times fruitful as well. But before we dive in, is there anything that you've been working on recently, or any just kind of updates on the stuff you've been researching or writing about?
No, mostly I've been, cutting the grass and, tending the yard and things like that. So nothing newsy on the ID front.
Right. Excellent. Good. Well, the case is closed then. It's all settled.
Mike, do you still teach?
Yes, I do. I'm still full-time faculty at Lehigh University. Okay. I teach biochemistry, physical biochemistry.
Excellent.
Cool.
I assume very well tenured.
I have been for a while. I got tenure before I wrote Darwin's Black Box.
I was just saying, I suspect that's coming very handy.
Yeah.
Well, before we dive in and see where this conversation develops, I'm sure it'll be very interesting. Mike, why don't, for people who might be new and to your work who haven't heard of you before, do you mind a sort of brief introduction and whatever you think are the relevant things for people to know about the work you've done in the world of ID?
Okay, yeah. I received a PhD in biochemistry way back in 1978. I did research on sickle cell hemoglobin, did a postdoc at the National Institutes of Health on the structure of DNA and chromatin, got a job in the chemistry department of Queens College, and then moved to Lehigh University in 1985. And during all this time, I thought Darwinian evolution was a good explanation, not because I knew how it could explain the complex systems that are seen in biochemistry, but because that's what I was taught by my instructors, and I didn't care. And I'm a Catholic, like yourselves, and I was taught about Darwinian evolution in parochial school, and we were told essentially that God can make life however he wants to, and this looks like a good explanation for it. That sounded fine by me. I didn't care. And so my work wasn't on evolution or anything related to that until in the late 1980s, I read a book called Evolution: A Theory in Crisis by a geneticist named Michael Denton in Australia, and he pointed out a number of problems for Darwin's theory that I had never thought about before and had never been mentioned in any of the classes that I took, going up to and past the PhD level. And I didn't have answers for them. And at that point, I got mad because I thought I was being led to believe something, not because the evidence for it was compelling, but just because that's the way we were supposed to think these days. Mm-hmm. And so from then on, I became very interested in the claims of Darwinian evolution. And I went to the science library and found that, in fact, nobody in all of the scientific literature had explained complex biochemical systems, a number that I have discussed in my books since then. And kind of serendipitously, I came to write some books on the topic. First one was Darwin's Black Box, that highlighted the very complex biochemical systems that have been discovered in the cell, and showed that none of them have been explained by Darwinian processes, and why they resist Darwinian explanation too. And I've written two further books, and I'll skip the second one, but the final one just came out 2 years or so ago, and it's called Darwin Devolves. And the kind of new twist there is that due to advances in science, we can now more easily track down the mutations that help organisms to adapt and survive in new environments. And they do. Mutations do come along, do help them adapt. But the great majority of cases are mutations that break or degrade pre-existing genes. And that sometimes helps, just like it would help to get rid of weight, maybe the doors on your car or the hood of your car, if you wanted to get better gas mileage. It's not as attractive, but if your survival depended on getting better gas mileage, you could do that. Right. And so I've been in this game a long time, and I become more convinced as time goes along.
Excellent. So Jim, you're kind of this is the first time that you've been in this type of roundtable. So I want to kick it over to you and see where you want to maybe guide this conversation or direct some questions to Mike. Mm-hmm.
Yeah. So I was in graduate school when the intelligent design thing kind of really took off in the late 90s and the early 2000s, right? Mm-hmm. And I wrote my dissertation on teleological explanation. So that was kind of, I didn't write on intelligent design, but it was kind of like, if there had been a sixth chapter, it probably would have gone in that direction. Uh-huh. And so early on, a lot of the stuff I wrote and thought about, I think my first couple publications were on intelligent design. And then I haven't really thought about it very deeply since probably like the early 2000s. But and my relationship to it has always been interesting, but not with a big dog in the race, right? So my approach to natural theology is very different than the design argument. It's not necessarily that intelligent design is even making a design argument, right? But there's I guess there's one, and it's kind of the stock objection, right? That you hear to intelligent design, and you may have done this in your latter two books. I've not read those two books, right? So I'd love to hear your take on this objection, right? If you don't mind, yeah, okay. So you'll hear this all the time, where whatever complex system we point to, such that to say that there's an incremental explanation, evolution by increments explanation of that, becomes so improbable as to strain credulity, right? And it's usually kind of the form of an intelligent design type argument, right? And then usually the reply you'll hear is, well, sure, that just means we don't know the explanation. It doesn't mean that there isn't one, and science always works, at the edges of where explanation seems to break down, and that's where the advance of science is, right? And so it seems to me that the stock objection I always hear to intelligent design is simply that it's a hasty move from a lack of an explanation to a claim that there therefore is not one, so we would have to go beyond science to get that explanation, right? Okay. I mean, like, one, I'd like you to reply, and even, do you see that as a fair objection to what you're doing, right?
No, I don't. I think it's a confusion. It begs the question.
Okay.
That assumes that intelligent design is not the answer.
Right.
It says, oh, your intelligent design idea, that's, we want a real answer. Well, sorry, that is the real answer. Mm-hmm. And let me give you give you an example of another phenomenon in science that had sort of a similar reception, and that's the Big Bang theory. Yeah. Back in the day, in 1930s, of course, up until then, most physicists thought that the universe was eternal and unchanging, and then the motions of galaxies away from each other and away from the Earth was noted, and that was the beginning of the Big Bang theory. And of course, that seemed to imply that the universe had a beginning, which had very theistic overtones. Maybe that was creation. And a lot of physicists did not like that. And they wrote about it, and a number of them said that the Big Bang is unscientific. Science requires that the universe be eternal. And nonetheless, despite opposition, the Big Bang seemed to be consistent with the observations, with the data. And so it seemed to be a legitimate hypothesis. If you see things rushing away from a similar point, then, hey, that looks like the aftermath of an explosion. And that idea still is resisted by many scientists. In the late 1980s, in the journal Nature, which of course is the most prominent science journal in the world, the editor wrote an editorial with a peculiar title. It was called Down with the Big Bang, in which he wrote that the Big Bang is a creationist theory, and that he looked forward to the next 10 years when the Big Bang would be overthrown. Well, that didn't come to pass. But the
Famously,
point is,
right?
The point is that, if you rule something out based on your philosophical preferences, that is not that's not legitimate. Science is supposed to follow the evidence wherever it leads. If it leads in one direction that seems to have some philosophical implications, well, we're scientists, we're not philosophers. If it goes in another direction, has different philosophical implications, well, again, we're just supposed to follow the data. So that's the way I kind of view intelligent design.
Right. So, just real quick, just for the gentle listeners as well, I think I think you would agree with this, Mike, is that it's really important that we don't stay too abstract with this, because the details seem to matter significantly for the argument, right? And so I wrote a paper I showed it to you, Mike, where I was responding to Paul Draper's kind of evolution by letters, but it's like, that's not really how this works, right? It's not just moving letters around. Like, there's a lot of detail here that we have to consider to give this a fair shake. So tell me if you think this summary is fair, Mike, and then clean up however you want. Is that, so you're known for the argument from irreducible complexity, right? Especially in the sort of in your special field of microbiology, right? That there's these systems, right? And the systems that are complex and function only when all the parts exist and are specifically arranged, right? And that if you remove any one of these parts, then the whole system is kaput, right? And the reason this poses a problem is that, say I don't know how many parts there are exactly, but there's a great number of parts, right, that we would have to get to. And there's a coordination problem where the parts have to coordinate to a specific function. And then there seems to be maybe not a logical impossibility, but a virtual impossibility of how we could ever select to that, right? Like how you could ever get to that point through a Darwinian process. That I think it would be fair to say, like, if the Darwinian theory was true, then like irreducibly complex systems would be virtually impossible. But it seems like there's a ton of them in biological life. So it would seem like, Darwin's theory itself is virtually impossible. Is that a fair summary? And if so, maybe you could just fill in some of the details so we can move away from the evolution by letter and just see like the stuff we actually have to deal with. Because I think that makes a significant difference in this conversation. Mm-hmm.
Yeah, I think you're right. It turns out that, in my view, Darwin's theory does best when you don't look too closely. And back when Darwin proposed it, everybody should remember that science was much, much less sophisticated than it is today. The cell was thought to be a little glob of protoplasm, maybe some sort of jelly. They didn't know how it worked. Atoms and molecules.
Explanation without structure is interesting, right?
Yeah, absolutely. Atoms and molecules were theoretical entities. Nobody knew whether they really existed or not. And with the progress since Darwin's age, we of course discovered that atoms and molecules are foundational building blocks of things, that the cell is far from just a simple blob of jelly. It's a coordinated factory with all sorts of impressive equipment. And it has been the very progress of science that has made the intelligent design argument more and more and more compelling, in my view, not only in showing the complexity and the purpose of many systems in the cell, but also, as I write in Darwin Devolves, showing that Darwin's mechanism of random mutation and natural selection tends to degrade cells and systems over time. Because since evolution cannot see ahead, it will take the quickest fix that works for the moment with no thought of the future. And oftentimes that involves throwing overboard stuff that is pretty sophisticated, and just living for the next day. And while that's fine, it can help species adapt to this or that niche. It is not something that's going to build complex machinery in the first place. So the more we know, contrary, it's oftentimes ID is called an argument from ignorance, but the more we know, the more compelling intelligent design becomes.
All right, yeah, Jim, hop back in.
And so, in your later work, what do you see as the conclusion of the argument? So the premise is irreducible complexity. I guess and the fact of the matter of how wildly improbable it is to get that right. What do you see then? Like, what is that? What's the inference to then from those premises?
Well, there's a couple of things. First, irreducible complexity has two major points to it, two edges of disorder or whatever. Because it's irreducible, there's machinery in the cell that's irreducible, just like a mousetrap needs all of its parts to work. It resists the gradual step-by-step explanation that Darwin's theory insists upon. And the second thing is that an irreducibly complex system that does something points strongly to design, because design, or the work of a mind, is apprehended in the purposeful arrangement of parts. When you see something here and something here put into relationship so that they can do something beyond themselves, that is the signature of a mind. Think of a mousetrap. It's irreducibly complex because if you take away a part, it breaks. But more than that, all of the parts have been put into relationship with each other so that it can do its function. And more and more I've been kind of focusing on this, that the only way that we can detect the work of a mind is through this purposeful arrangement of parts. We do it when we speak. We arrange sounds so that they can convey a purpose. We do it when writing. We do it when we make a machine. We arrange things for a purpose. And now we see this in spades in the cell. And so the simple idea of ID is that we can conclude the same thing. We can conclude that those things were purposely arranged. They are the work of a mind. Now, as I've said a number of times, intelligent design as a science only has the evidence to go that far. Who the designer is, how it was designed, when it was designed, and so on, those are still open questions. They might be able to be answered in a scientific fashion, but they're still open. It turns out that if you think something is designed, that's the first thing you think about it. You look at a Mount Rushmore And if you don't know who did it or when it was done or anything, you know it was designed. And those other questions only arise once you think that something was designed. So my take on the biochemistry, the conclusion is that those things were designed. Now we can ask the other questions.
Right. Let me just a few other points of clarification that I think are always important and common stumbling blocks. The first one is that in your critique, at least anyways, of evolution, Mike, it's not we always have to emphasize that evolution is sort of an accordion term, right? It constantly expands, it contracts depending on who's using it, of what it means, right? And you know, there's certain aspects of evolutionary theory which I think that you affirm, like common descent and stuff like that, right? But what you're saying is it's the mechanism. It's the mechanism that's purported to drive it. That's what I'm challenging, right? So I just want to put that out there. Other people might deny other aspects. That's fine, but that's a different conversation. You're saying no, it's the mechanism that's under critique here, right? And
Right.
then the other thing yeah, go ahead.
Could I just to add that it's one word in Darwin's theory, and it's random mutation plus natural selection. And for my money, all or 99.9% of the philosophical and theological and scientific impact of Darwin's theory is in that one word. That is, can random processes, ones that aren't directed by anyone, specifically including God, can they be sifted by some process like natural selection and yield the immense complexity and elegance and all sorts of stuff that we find in biology? This stuff about common descent or other things, that's kind of a sideshow. It's the randomness. And if I can make a point about Jim's early paper. I think I read one of his earliest papers after graduate school, and at the one of the final footnotes in the paper.
Oh my gosh!
I'm sure
pick this thing up. Yeah.
Mike's thorough. If you've read his books, you'll see he's thorough. Yeah.
Awesome.
Well, this is actually a common point. It's not only yourself, Jim, but Steve Barr, a physicist and a guy who's active in Catholic academic circles, holds a similar point. They say, let's separate the neutral Darwinian theory from this atheistic materialistic view of Darwin's theory. In the atheistic materialistic Darwin's theory, people say, oh, this shows that God wasn't involved, or this shows that only the matter and energy and laws of nature are sufficient to explain stuff. But in the good, I think you said philosophically naive Darwin's theory that just says, oh, it's random, but does not make these other claims. Well, that might have worked, or that might be a good theory of evolution. And I could say a couple things about that. First is that everybody in the world, especially in the scientific world, uses Darwin's theory, the phrase Darwin's theory, to mean no guidance by nobody, including God. As a matter of fact, in 2005, there was a group of 35 Nobel Prize winners who took out a full-page advertisement in the New York Times specifically saying that by evolution we mean an unguided, unintelligent process of whatever. So they specifically mean that. And the phrase Darwinian evolution, Darwinian can have any meaning they apply to it. It's not like saying, it's not like applying a proper name to it. And by that, they do mean this other more objectionable take. I appreciate the fact that Steve Barr and stuff want to convert the world to thinking of that phrase as somewhat more benign, but I don't think one can. And the second very important point is that there's no difference between the two, between the benign one and the non-benign one, because in the non-benign one, it's saying that that random mutations, yeah, okay, they're just random. We can't figure out what they are. They, when sifted by natural selection, can build the eye, can build the flagellum, can build anything. So even if you give God, gravity and say electromagnetism, but say, the question is, beyond gravity and electromagnetism, did God have anything to do with life? And you say, well, maybe not, because Darwin's theory seems to account for it. What you are saying then is that accidents, unplanned mutations sifted by natural selection, say the type of mutations that you get when you live in New Jersey next to a chemical factory that lead to birth defects and cancer and stuff, those things, every now and again, those can add up to eyeballs and flagella and so on. What's more than that, you're saying if you have this substratum, then chance can take over from there. And there is no need for intelligence to explain the very phenomenal things that are discovered in life. To me, that seems, that doesn't sound good, because if you have a system that exhibits finality, purpose, and so on, the greater the finality, the more you should be able to say this exhibits purpose, this required design. But if you can't tell that an eyeball was designed, how can you tell that light was designed, or that the photon or electron was designed? The laws of nature are much more general. Things in biology are much more specific. So I think one can have greater case for design in biology than in physics or lower natural laws.
Yeah. It's
so Michael, do you think that you could say what we mean by random is relative to how high order perspective we're taking? So you could say something, given the epistemic, tools available, or maybe even like the rules of the game at biochemistry, something will come up random, meaning like we don't have explanatory resources to give an in-principle explanation of this event at this level, though at a higher order, we could see it's not in fact random at all, right? So at the biochemical level, it's random, but if we could look at it from a broader level, at the chemical level, in fact isn't, or something like that, right? And so it seems like, to me, I've always thought about randomness in biology, or in evolutionary theory, to say, yeah, it's within the rules of the game that are frequently the way that science is played, right? I don't mean be flippant by saying playing, right? Okay, but given the standard rules of the game, this is going to come up random, meaning there is in principle no per se explanation for what's going on there. However, that doesn't mean it's uncaused, and it doesn't mean there isn't a teleology to it, though that teleology might only be accessible from a higher order discipline, say, metaphysics or something like that. Yeah. Right.
Well,
if I may also, and I think like people who want to go from randomness in that sense to infer ergo unguided, well, that's invalid, right? Okay, by all means, right? But also, I think to say, well, to broker randomness there means you're going to have to go the route of, what's his name? Nagel calls, the atheistic materialist Darwinist perspective, right? Which he thinks is defunct, right? Do you know what I mean? I think there's kind of a bad inference to be made in both directions there if we take too substantively what's meant by random?
Well, random means that it's undirected. Random mutations, biologists use that to mean it's undirected for the good of the organism.
Right.
That it's just happens, and if it happens to help the organism, then it is selected, but usually it doesn't. Well, now, unless God is guiding that, if God were guiding it, then it's not random. If God is not guiding it, then we have the same problem that you can get order, you can get apparent design out of some unguided process. So I don't see the advantage to saying in retrospect, we can see the teleology coming out of it.
Yeah.
What do you say to somebody who says, well, in retrospect, we see that randomness can give rise to order, and you were mistaken in your premises in the first place? That so you can have, when you unexpectedly get something as magnificent as, fingers and hands and so on, you can say two things. Well, clearly the amorphous stuff from which they came was not really amorphous. It was planned, or it was guided, or it was set up to produce these things. Or you can say, why, look, we got these things from something amorphous. Therefore, amorphous stuff can give rise to order. And the latter is what biologists routinely do these days.
No, and I'm agreeing that's a bad inference.
Yeah.
Yeah.
Let me see if I can. Yeah. Just
to
maybe
say that this change was unpredictable from like the prior structure and life of the organism, or even the substructure. Therefore, when it came out, it was random and unplanned. I think that's a bad inference, right? I agree wholeheartedly, right?
Mm-hmm.
Okay.
But I just think that there can be, like, you can grant that, because I think what is or isn't random is relative to the kind of explanation that we're looking for, or that we could give given our first principles within a discipline, right? So I think you could grant it's random given the resources of biochemistry or something like that, and yet say in the biggest picture possible, it's not at all random.
Right. So
right?
yeah, let me because I think maybe my progress of development of thought on this might help to clarify this question or this statement, right? So I moved away from naturalism to theism primarily because of the metaphysical arguments, right? And like evolution was just sort of this, it just didn't really factor into it, right? Because I became convinced that, yeah, in order to make sense of contingency, we need a purely actual reality. And so, like, whatever else we want to say about evolution and selection mutation, like, it seemed like in principle there was nothing out of bounds of God setting up different lines of causality that would lead to the development of life. Now, how he did that, I have no idea, right? But maybe if I just looked at the biology itself, I wouldn't see those different lines of causality. So it might seem random from that perspective. But from the greater metaphysical perspective, it's really not random, right? That's kind of what you're saying, right, Jim? But then as I read Mike's work, I became convinced that no, actually, I don't know. I think there is a valid inference, to be made in a sense. And I think maybe it connects to Aquinas' fifth way a little bit. And I just want to be very careful. And I got a little pushback in my conversation with Stephen Meyer, even just internally with myself, that I don't think what Meyer or Mike is doing, at least not what you intend to do, is like giving an update on the five ways. I think these are different projects, right? But they share similarities, because we would say Aquinas is really doing metaphysics, right? And that's sort of grounded in some would argue in philosophy of nature. Mike, you're giving a really just sort of an empirical argument against a scientific theory, but we can still have inferences from it. And one of those inferences is this, right? Is that if there's relationality, right, that is a hallmark of conceptual ideas. And conceptual ideas, of course, is the hallmark of a mind, right? Now that is exactly what Aquinas uses with his fifth way. Now you might say you can launch the fifth way from an electron, and you already said that, Mike, right? Just the directedness of an electron, and final causality. One of the issues that people have with final causality is it seems like, forget an electron, take an oak tree, right? It seems like the oak tree is in some sense the cause of the acorn in its progression, right? But how is that the case if the oak tree doesn't yet exist, right? How can that really be a cause if it doesn't exist? And Aquinas's answer is it does exist in the mind of the prime thinker, right? And that's how he bases that. And it's all about the relationality and conceptual ability. Now that's, again, a different argument in details, but I think there's enough similarity where you're saying, well, look, in these biological systems, we have relationality, right? And we have finality as well. Now, since it's not a metaphysical argument, maybe we can't get to pure actuality or the prime thinker, but it seems like we can at least get to conceptual ideas, which gives us intelligence from within the realm of biology itself. Do you think that's a fair way of putting it?
Yeah, I certainly do. And I agree with you folks that science cannot get to metaphysical truths, or certainly can't argue to God as Thomas Aquinas did. But given the proper limits of science, I think ID is just what you would expect from a Thomistic perspective. That, in fact, purpose, when we see bodies acting for a purpose or towards an end, we always realize that there is an intelligence behind that. And we see these, again, everywhere in biology. The one difference, I think, is that Thomas used simple examples like an archer or something falling down. He did talk about an oak and an oak tree, but that turned out to be more complicated than the archer and so on. But here's a question maybe you philosopher types could answer. If you see that there is intention or causality on one level, like say things falling down or archers shooting, does that automatically mean that everything is intended, everything that happens from that? For example, using the archer as an example, the guy shoots arrows and they go here and there. Okay, most of them hit the mark. But suppose the archer sent a number of arrows and it spelled out tantum ergo sacramentum, okay, on the wall. Could you say that could you conclude that beyond the archer shooting these, he intended for that phrase to appear on the wall? I think one can, of course. But the problem is, suppose somebody else came along and said, well, look at the, yeah, sure, he's intending that, but there's no evidence to show that he intended the higher order organization. He might have just intended to shoot the arrow, but not to make tantum ergo sacramentum. In the same way, you can talk about electrons and you talk about gravity, but does that entail that the things that they eventually do also were intended, also were guided or guided to the mark, like the archer? And if you don't, if you say that there are these other things can develop without intention, then it seems to me you're saying that chance can do a lot more than I think Thomas Aquinas would think. So the question is, at higher and higher levels of organization, suppose you had a mark in the form of a letter T or something. Okay, well, yeah, that looks like it was designed, it's making a T. And you put an HE next to it. Did those letters arrange themselves by accident? and then it says the cat sat on the mat or something. Well, how about that? Is that organization of the sentence, is that intended beyond the words and a paragraph and then a book and an encyclopedia? I think in our ordinary world, we recognize that each of those levels of design were intended for themselves, and they would not arise from the lower levels without intelligent input. And I think empirically, we can say the same thing now that science has progressed. You know, if we had turned out to be blobs of protoplasm, maybe we couldn't say that. But now that we have found how extraordinary is the cellular and molecular levels of life, I think we can, just like writing an encyclopedia is a further act of intelligence beyond just writing a sentence, I think we can say the same thing in biology.
Yeah, that's a very interesting argument, Mike. I haven't heard it put that way before. Maybe we'll come back to the fifth way stuff in a bit, right? I want to because a couple times you've appealed to linguistic analogies with language, right? And I'm inclined off the cuff, without giving it a lot of thought, to say, yeah, if you're going to say this, this sentence, this proposition is in fact bearing intentional content, then it's going to be difficult to say that the process is bringing it about, right? Don't bear intentional content, unless though you already have a kind of top-down causation. Like if the sentence, this is a step in a conversation, and the prior steps in the conversation have a top-down effect on what goes on at the lower level, right? Then that might be a different case. But I think that's probably not relevant in what you're talking about, because you're mainly talking about, like, how do we get the bacterium off the ground in the first place, right? You're not really talking about succession, right?
Right.
Does that make sense? So I'd say that once you have an organism up and running, I think you could, if somehow you got one up and running without intentional processes, but intentional processes came up at a higher level, they could have downward causation, and they're kind of running it top down now rather than bottom up, right? Which actually I want to talk epigenetics later too. So anyway, okay. And anyway, but I'll say this though, just about using the analogies with language is, we went in for the sentence you spoke because we had a pre-given sense of Latin pronunciation and the role that sentence could play in a conversation, right? That we were already participants in a meaningful language game before you use that example, and it's that prior participation that let us recognize that as linguistic. It wasn't just the complexity of the stuff arranging; it was that we were already up and running in the language game to recognize that, right? And I wonder if critics, though, when you say, hey, in the same way that we can recognize phonemes forming words, forming sentences, right? We should be able to recognize, proteins and lipids forming, more complex things, forming organelles, forming organisms as structured. But in the language case, it's that there's already a background understanding of what we may or may not be being told that we're bringing to the field that lets us recognize the meaning, right? Whereas that it seems like we can't front load it with the expectation in the biological case. Does that make sense? So I think that analogy is going to break down there, right? And because that's not exactly how language works. We don't build up from phonemes, right? Right.
Yes. Well, I'm not sure I agree. We do have, with the development of science, we now do understand a number of physical principles and engineering principles that are necessary to make machinery work. And what we find in the cell is machinery. And just to go back to the bacterial flagellum again, we know how you make a rotor, and we know what parts are needed. And I'm sorry, go ahead.
But because I'm gonna forget otherwise, but we don't infer intentional design of the parts to the whole from speech, because I don't intentionally design my speech from parts to whole. Okay. Whereas what you're asking us to do here in the analogy is to infer intentional design from parts to whole in the case of machinery. And I agree with you, in the case of machinery, we do this, but we don't do this in the case of speech. Right.
That's true, because we have a lot of experience with it. But if you
Right.
went to another planet, say, and there was some strange looking creature going, well,
Yeah.
you might start to try to build that up exactly that way. And you'd say, how intelligent is this creature? If you did, you say, well, it says, ba. It turns out that means, food or something. Well, okay, is it smarter than that? And if it could make more and more and more, the better it could.
It's not going to work, though, at the level of phoning up, right? It's going to work at the level of they're going to make certain noises in certain semantic situations that I'm going to make a charitable assumption about what they're doing, right? So I'm actually going from I'm imposing my whole interpretation on their world, right? And working down, and then I'm going to test that. Do you see what I mean? It's not going from pieces up, right?
Well, it's not. You would have to have a number of pieces first, and you would say, it's not just it's ba cha or something. When they put those together, when they arrange those together, they and you now discover that they mean food.
And is it not just pieces, but again, I would say relationality, right? And that's kind of what's unique about language is there's, if you analyze the sentences we've used, there's only few words that we could actually put images or pictures to, right? And it's the ones we can't put images and pictures to that differentiates from the monkeys, presumably, right? It's the distinction between the perceptual and the conceptual ideas. So is it really not just about the parts, but the relationality, right?
Yeah.
Design
is the purposeful arrangement of parts, like in the mousetrap. Each part by itself, when they are arranged, they have this function now, and we can immediately tell that it was purposely designed.
Yeah. But see, I guess what I'm disagreeing with is not that. Okay, right. It's this idea. So I agree that we humans have this theory of mind that comes pretty hardwired with us, right? Where from certain phenomena we infer, not explicitly, but we seem to operate under a practical assumption that what we're talking to is smarter than us, as smart or smarter than us, right? This is integral to human cognition, right? But we don't do that by assembling bits of phonemes, right? Or even pieces of faces, right, into faces, and then thereby making the inference, right? It always begins from an overall gestalt and works down, right? And even using the example of the radical translation case, right? I mean, it's like we don't learn language like one piece at a time. We don't say, this is green, Johnny. This is blue, Johnny, right? Because that presupposes I'm not talking about vessels, or I'm not talking about liquids, or I'm not talking about all these other things, right? So language always works like a whole interpretation down, not from pieces up, right?
Well, that's if we think that we're already speaking to an intelligent being. If we didn't know if this being was intelligent. Here's an interesting story that I wrote about in Darwin Devolves. It has to do with this editor, a French editor of the magazine Elle, E-L-L-E, and he had a stroke in the 1990s or so, and he couldn't move. He was in a hospital bed. He couldn't move a muscle except for his left eye. He could blink. And he dictated a book called The Butterfly and the Diving Bell about his experiences as a paralytic. He had something called locked-in syndrome that allows somebody just to blink an eye. Now, anybody walking by his hospital bed, you'd think he was a vegetable. Don't know. He couldn't make any phonemes. He couldn't do anything. He worked out a code with a translator in order to make his book. And we could tell his level of intelligence. You know, he could have any level of intelligence after his stroke, you know, from what it was before to, you know, nothing. We could tell his level of intelligence by interpreting the arrangements of his winks. So
but they already had French up and running though, right? I mean, like the other person could come in and say, if you can hear what I'm saying, blink once, right? And then and then build from there. So they're already there's already a background French that they're operating in, right?
Yes.
Yeah. And so
that is a purposeful structure as well.
Well,
so
I mean, but French isn't purposeful in the sense that somebody sat down and designed it.
Well,
I mean, nobody's running French.
It is purposeful in the sense that anybody who uses it chooses their words in order to convey information. And you can do that with French. If the person you were talking to was deaf, you could use sign language. You could try to arrange pieces of, you know, something to, you could rub your belly to say that you were hungry.
Yeah.
All of those things, though, you're doing those for a purpose.
Yeah, I agree with you. Yes. Although I wonder,
I don't want to get stuck too much on human language because that's not, you know, as you know, directly applicable to biology, you know, unless you want to talk about DNA and the information in DNA.
Yeah.
But yes.
So I guess one thing I'll just maybe and then Jimmy, get the final thought on this so we can move to another one, because I think that there's a lot of interesting lines of thought in here, right? And I've been thinking about language and concept possession and this or that, and maybe just about concepts in general is really fascinating to evolutionary theory, right? So the idea, one of the arguments for the immateriality of conceptual thought is its determinate or exact content, right? Which speaks against materialism, because anything material is limited, it's imperfect, right? There's always any number of ways that we can conceptualize over and above the physical facts, right? So it seems like the space of causes can't fix the space of reasons, right? And so there's this sort of determinate, unambiguous, exact content that comes with conceptualization that cannot be reduced to the physical. Now, it seems to me in evolutionary theory that this is assumed when we say that something is selected for, right? You see what I'm saying? Like there seems to be a determinate fact of the matter, even within evolutionary theory itself. Now that's teleology, right? Now that's a different argument that you're making, Mike. But I mean, unless, and I don't know, do scientists ever say that there's no fact of the matter of what's been selected for, or is it?
Oh, they say that a lot. Yeah, they will say it's selected for survival, and if it happens to be because it's resistant to some antibiotic, they might say that. But of course, it's a tenet of evolutionary biology that there is no such thing as real purpose.
Right, but take your polar bear example, right? Is the polar bear selected to be white, or is it selected to suit its environment?
Yes.
There's a difficulty here, right? There's a difficulty. I don't know, that might be unrelated and get us too far off the matter, but it seems to me that in order to really cash out and make sense of what's going on, even in biology, we're going to have some type of meaning when we talk about selection and mutation, right?
Yeah.
And that I think even just that meaning itself speaks of conceptual ideas. right? Now that's different than Mike's argument. So I don't want to take us too far aside, but I think it connects at least to some of the stuff that you brought up with language, Jim. So I'm trying to be a bridge builder here. You see?
Oh no, I'm having fun talking about it, so there's no. Yeah.
So I want to hear about epigenetics. What do you think about?
Sure. Okay. I wanted to look some of this up before we chatted, but then we had to move it up. So if I am like completely botching the scientific side of this, please like point me out to be the ass that I am. Okay. But I recently had read something about I want to say it's the PAX7 gene that is related to, I think, it was eye growth, right?
Yes.
Okay. And the idea is if you took the PAX7 out of a mouse and you like put it in like, the hind quarter of a fruit fly, it won't grow a mouse eye. It will grow, a fruit fly eye in its butt now. Right. Okay. And likewise, if you took it out of the fly and you put it in the hind quarter of the mouse, it's going to grow a mouse eye on the haunch. Okay. Not a fly eye. All right. Okay. I find this absolutely fascinating in terms of like a counterexample to the selfish gene business. Okay. Because now that gene's work is determined by its position in a whole living thing, right? Or it's partially determined, right? It's a two-way thing now. And so it's not just that this organism is at the service of the gene, right? The gene is as much at the service of the organism too now, right? That indeed there is a downward causation on the gene from the living thing, and it's not all bottom up, right? And so now you've got living things with a kind of autonomy from the supposed genes they were selected for, right? And to me, that's kind of a game changer, right? So it's a different problem than what you're worried about, because this is all assuming we've got things up and running, okay? But it would seem to show, like, once you've got stuff up and running, to say that it's simply we're going to read this off of and you get all these like bad teleological metaphors built into this, like what the genes want to do, where the genes want to go, all that dead letter, right? Because indeed, it seems like that you can say the organism has just as much a case for running the show as do the genes.
That's absolutely correct as far as I'm concerned. There's a whole new field of biology in the past 20 years or so called systems biology.
Yes, yeah.
And
I get a flutter when you say it, Mike.
systems engineering, and these are engineered things. The interesting thing about the PAX7 is that it's pretty much like a switch, like a light switch or something. Okay, you unscrew the light switch from the wall here, take it over, put it into a different, circuit, and it works. Okay, it's works, and it'll turn on whatever that new circuit is hooked up to do. But by itself, it's not doing much. It's just a tiny piece in a organized system. Okay. And if the organization weren't there already, it wouldn't do anything.
Right.
So
nor would it ever been selected for, right?
Well, it wouldn't even, you wouldn't, if it weren't there or something else, it wouldn't be selected for. None of the other stuff would be selected for either, at least in regards to the eyeball, which perhaps you can see is the problem with Darwin's theory of gradual, building up of stuff.
And have you heard a term? I'm going to probably botch the pronunciation. Autopoiesis, associated with a biologist named Valeria.
Yeah, autopoiesis. But tell me more. I haven't followed it close.
The idea is that, and it's actually you can find this in Kant's Third Critique. It's like, although I don't know that that's where Valera's taken it from, but I know some of his followers have made the connection. This idea that what an organism is, or a living thing is something where the parts of it cause each other, right? Now, once again, your question: how the hell do you get that off the ground? Okay, but the idea is this enzyme is there and it does what it does only because it's interaction with this other enzyme doing what it's doing. Okay. And so now at least Kant looks at this and he says, well, these organisms in a way are self-caused, right? Because all of their parts only make sense together, right? They only make sense together. Okay. And then also this is where these like people of Valeria go with this, is to say, well, look, what happens then is these parts determine what is or is not informational to that organism in its environment. Okay. It's because the parts are determining each other in this way that a certain thing is a nutrient as opposed to a poison to this particular organism. Right. So now I think this is very interesting from how we make sense of, say, so-called randomness in evolution, because now it's not just environmental push on the organism that's running things. It's also the way the organism structures itself, right, that creates what is or is not a meaningful part of its environment. Do you see that? And so, like, once again, you're seeing organisms as having a kind of autonomy, not just from their genetics, but even from their environment in a way, or a kind of determining what is or is not a meaningful part of their environment is based on this internal dependence of the parts on the whole, right?
Right. Absolutely. Organisms, animals and plants have, built into them ways to adapt to their environment. If the environment changes, if it gets hot, dogs shed fur. Yeah. When it gets cold, they grow more fur. And there are surely more complicated examples. Yeah. But, if a meteor comes in, there's not much a dog can do to survive in the environment. So yes, it is the organism which determines what is a signal and what is random. Right. And that's certainly the case. But that's certainly the case. Yeah. I was in a meeting recently between biology or ID folks and engineers, sympathetic to ID. And they were saying that, we get a lot of closed systems that are closed all the time, or one part works on another, which works on another, and it's auto. Yeah, that
was the phrase I was looking for, was closed. Yeah.
Yeah. But they say it gets there because we make it. It doesn't make itself.
It didn't call. I always push back on like the self-caused idea, because that always it hurts the brain to think of something causing itself. But I know that wasn't exactly what you meant by it, Jim. It just means there's a sort of
it's Kant's phrase. Yeah.
There's an explanatory vicious circle in these types of situations, right?
And something that strikes me right now is, okay, so to me, because of my kind of Aristotelian commitments, like these are kind of the important issues to me, is to see the organism as having an integrity over and above its genes, over and above its environment.
Right. That it has a substantial form, right?
Yeah, it's a substance. But what's interesting, and this is probably a blind spot to my own Aristotelianism, Mike, is, Aristotle does not deal with the problem of origins of these things, because he doesn't think there was one. He thinks the universe is eternal, and he thinks all the species are eternal, right? So you never in Aristotle get a question of how you got the first one, right? And even in Aquinas, because he's pretty comfortable with a discrete single one morning God makes the universe boom thing, right? So he's not really interested in a complex scientific story of how you got your first one, right? In a lot of ways, these problems that we're bringing up here don't really occur to that kind of Aristotelian classic tradition, right? And how we adjust to that, it's an interesting question. And I hadn't thought about that problem just till this very moment.
Right. Well, some of these explanatory vicious circles are interesting because at least Aquinas would say, well, we have certain composites, right? Like a matter-form composite, where you can't make sense of it just looking at the matter-form composite, right? Something beyond it has to have put these parts together, right? And that is a purposeful arrangement of parts in a broadly loose sense, a more metaphysical sense, or essence and existence, for example, for Aquinas. Now, I wonder, Mike, if you have other examples of this, and I know we were chatting through email. I'll just throw it out there. We don't have to talk about all you want, but replication always seems to strike me as maybe one of these issues in biology, because the way I see it is this, right, is that to really make sense of evolution, you need a channel of communication, right, to pass down these traits. However, it's often, it seems to me, an assumption that channel of communication is something that evolution is supposed to explain, right? So now we have we have an issue again, right? Like we need this channel of communication, but to explain this thing, but this thing that needs to be explained is supposed to explain the channel of communication, right? Which is replication. And I don't know. I've really tried to look for good answers to this riddle. And of course, you go to origin of life sciences, and there's just all of these well, maybe there's proto replication, or like there's a parallel to philosophy of mind, Jim. Like, you know how you try to have fading qualia in philosophy of mind. They have like fading replication in a sense. Actually, John Haldane makes this the example, right? And in the same sense, if you think that fading qualia doesn't make any sense, you definitely shouldn't think that fading replication makes any sense. So it just seems like there's like an in principle explanatory problem with that. Not just like a very improbable, and I'm fine with probabilities too. Like if something just seems so improbable, I'll reject it. But it seems like there's certain points that are just in principle issues. So Mike, any comments you have on that? And then where would you classify your arguments? Do you think it's just a matter of enormous improbability to the extent that it's just so improbable we should just go where the evidence leads just because of that? Or do you think it's more than that? You think it's an in principle problem?
Well, let me first say that about replication, that I think that's a great example of Jim's autopoiesis. That one causes the other. That talking in terms of biology, we need DNA and we need the proteins that it codes for that actually do the work to replicate the DNA. And with origin of life, people will these days talk about RNA and the RNA world, where they fancy that RNA can act as a catalyst and also as a genetic information carrier. So maybe somehow that got together. And there's, as I'm sure you've seen if you've looked into the origin of life literature, there's enormous problems with any of these scenarios. But the problem is they're empirical ones. And so you can't say, you can't definitively roll them out in the sense of a mathematical proof or a philosophical proof. And you also have to realize that no matter how bad it gets, no matter how many things don't seem to work, a materialist will always have something else to say. They will never run out of ideas. So at some point, you just have to shrug your shoulders.
Right.
In a sense, irreducible complexity is the same problem as the origin of life, in that you have to get the genetic information for it, and you've got to get the thing itself. And like the origin of life, people say, well, maybe this happened first and helped a little bit, and then this helped a little bit more. But when you ask for details, they are not forthcoming, or they're only hand waving.
Right. So maybe we could give an example. Like this came up in the discussion you had with Dr. Swamidas, exaptation. Right. This is probably one of the most common ones, right? Well, maybe this thing was co-opted from over here, and then this thing was brought in from over here, and then they somehow rearranged one thing, shortened, and then they coordinated to an entirely new function. Now, to me, again, I've always found this completely unbelievable. I mean, if you just replace all that with the word magic in a textbook, I don't know if you lose any meaning whatsoever in terms of in terms of an explanation. But maybe you could build on that a little bit, right?
Well, with things like that, with exaptation or other things, the problems only occur when you start to look a little more below the surface. Then they never happen. And as I talked about in Edge of Evolution and in Darwin Devolves, these fancy processes that are invoked are nowhere to be seen in nature when we're looking at evolution in real time. I talk about the development of resistance to chloroquine by malaria in Edge of Evolution, and there were an enormous number of opportunities for something to happen, and yet the only thing that was effective was a small change in one protein. And in Darwin Devolves, I talk about Richard Lenski's experiments with E. coli, the bacterium E. coli, growing it for 50,000 generations just to see what would happen. And it improved, it grew faster, it did lots of stuff, but it did so by breaking genes. It didn't get any new gene, it didn't get any new molecular machine, nothing like that. So when you look for these things, they aren't there.
Right.
And it all boils down, I think, to purposeful arrangement of parts, because blind processes can't arrange anything on purpose. By accident, something might fall next to this here, and that might help a little bit. But if you need, a bunch of parts to make a mousetrap, even a simple little mousetrap, which is, a toy compared to the molecular machinery in the cell, in 25 years, I still haven't seen a convincing, even on paper, explanation for how you could develop a mousetrap step by step in a Darwinian-like fashion. So at some point, at least in science, you got to, say that, no, this doesn't work anymore. And look at.
May I ask you a question with the mousetrap metaphor?
Sure.
I've heard an anecdote about like you can like break a piece off the mousetrap and like use it as a tie clip, or you could use it as a piece of jewelry or something like that. And I've often heard these objections to ID to say, well, look, I mean, maybe all these other prior parts have played, life conducive roles in prior versions of the organism, or in that organism stream, and therefore, it was selected, like all these parts could have been selected for other reasons, right? And then were together in the gene pool of an organism when they came up as useful in conjunction, right? Do you find those objections at all plausible?
No, I think they are just meant to distract from the problem. I discussed this in Darwin's Black Box way back in 1996. I says, well, suppose you wanted to build a mousetrap from just spare parts that were lying around a garage. And so for the baseboard, you took a wooden plank you had, okay. And for a spring, you look around, well, there's a spring in the grandfather clock over here, I'll take that. And maybe for the holding bar, I've got a crowbar over here. But of course, those wouldn't work together to make a mousetrap. You've got to fit them to each other. They have to have the same proportions. They have to be very closely matched. And none of those other things, since they already have jobs to do, they're going to be fit for their jobs, not for the job of making a mousetrap. So instead, the problem is switched to having to adjust all of these things, having to form them, and you still won't have a functioning mousetrap until all of those parts are fit to each other. And the other thing.
Yeah, finish your thought. I'll chime in. Yep.
Yeah, the other thing is Ken Miller of Brown University talks about the tie clips, and he says he can use other things as paperweights. But I would like you to go back home, or maybe you're home already, and find a tie clip in your door and ask yourself, is this on the way to becoming a mousetrap? I asked Ken Miller the same question at the New York Academy of Sciences way back in the early 2000s. I actually asked the audience, and I says, does anybody have a tie clip that looks like it's a mousetrap? And if you do, you probably don't get many dates. The point is that a tie clip would be fit to its job of clipping ties. It wouldn't be fit to be a precursor to a mousetrap. The other things he talked about the any part could be used as a paperweight, he said. But if you look online at paperweights, none of them look like a piece of a mousetrap. So one problem with minds is that these guys are intentionally guiding things. They say, he's challenging us to make a mousetrap. So, okay, we'll start with this and we'll guide it all this way to form a mousetrap. And they are the intelligent agent then that is essentially building the mouse.
I have
just an honest, like scientific layman's question. Do I have to assume though that in order for something to be selected as a tie clip, it would have to function optimally as a tie clip as opposed to some other role it might play accidentally in the future? Like it could be a pretty bad tie clip, but just good enough to get like an ugly date, right? And it would still, right? It would still keep things running, right? I mean,
it would, but now suppose that you've got your ugly tie clip, and somehow it gets bent or something, and selection would form it to be a better tie clip.
Right.
It wouldn't cause it to remain as clunky. There would be no selection to select it to be a part that will later be added to a mousetrap. So selection, I argue in Darwin Devolves, is actually a problem for Darwinian evolution, because it is expected to hone different parts for their present role, not for a future role, not for a past role, for right now. Mm-hmm. And therefore, they're not going to be, to the extent that they can be specific, they're going to be specific for their current role and not for some putative future role.
Right. And this is where I wanted to say just two quick things. One is it was actually, because when I was first looking at ID, I always try to say, what are the best objections, right? Because objections are argument testers, right? And whatever else anybody agrees or disagrees with here, I think we can all agree that we don't want to believe something that's false, right? Can't imagine anyone would argue with that, right? So I'm the same way. Like I try to look up what are the best objections, and Ken Miller came up right away, and the mouse and the tie clip stuff comes up, and I have to say it was finding those not just unconvincing, but seeing that these were considered some of the best objections was really surprising to me, because my initial kind of impression of ID was this is just dumb pseudoscience, right? So like this should be easily refuted, and then I get this impression that, well, it's not. Maybe it could still be refuted, but it's not being easily refuted. So there's something of a the PR on this is kind of off a little bit, right? So it just starts making me want to look deeper into it, and then I start looking into the details, right? And I'm like, oh, okay, this tie clip thing doesn't seem to work for a couple of reasons. One is that the fitness and the specificity of the parts really matters, but then again, there's the number of parts and them all being co-opted towards a new function that just seemed to me, if that, like, how can you do that, right? Like, how could that ever, because like an outboard motor, right? Like that's what we're talking about, the flagellum, right? The parts have to be well fitted, and correct me if I'm wrong, Mike, but they have to be well fitted, right? And they're coordinated toward a particular function. How could you ever grab how many ever different parts from functions they're already serving that aren't fitted for that particular role, and then coordinate together to perform a completely different function? I've never heard a good explanation for that. Maybe I just haven't, and believe me, I've looked, but these sort of like just so stories, I agree. Like they only seem to work if you just don't look into the detail. And then once you start to kind of look more into the details, I think that they quickly start to lose their plausibility in many cases. Mm-hmm.
It's poignant to read the literature on the flagellum from people who are just working on the flagellum. And there's one Japanese researcher, Kichi Namba, I've forgotten exactly what his name is. And at the end, I think this paper's from 2020 or 2021, very recent, that shows, the flagellum actually has gears in it. It works by a geared mechanism. And at the end, essentially, he says, we see the divine, complexity and elegance of it. But he said, I'm a materialist. So I just say, it's wonderful what evolution can do. And that's it. Nobody has shown boo about how these things could have evolved in some realistic fashion.
Right. So one more point, because I want to say your case is at least twofold, right? One is that we have this sort of broad conceptual difficulty with Darwin's theory. It predicts something, and what it predicts is not what we see, right? It would not lead us to expect irreducibly complex systems. We find those. This seems itself to be a strong mark against Darwin's theory. But then you have a further case, and that case is, well, now we've actually been able to test Darwin's theory as well. And what we find is that it doesn't build complex new systems at all. And it mostly functions by breaking, blunting, or degrading. Right. Exactly. So we have like two fundamental difficulties here. And I guess the question is like, yeah, you can always give stories, right? But at what point do you give up on those stories, right? I guess there's no logical impossibility for me of thinking that the Great Pyramids were built by a series of sandstorms. I guess that's logically possible, right? But it seems like there's a huge conceptual difficulty in imagining that, and there's tons of empirical evidence against it, and right,
especially if you then go inside the pyramids and you see the structure inside of them, that makes it even worse for an accidental. And that's what we're doing in biology as it probes deeper and deeper.
Yeah.
On that though, Pat, I mean, and this might beg lots of questions, but I think the reply you're going to get is, well, what if the sandstorm hypothesis taken in isolation is a probabilistic bottom feeder, right? Okay. But if it's an entailment of a theory that's got a lot of going for it, that's got a lot of probabilities behind it, then it seems like you're going to accept that probabilistic bottom feeder, as the best we can do at the moment, and kind of hold out to see if somehow the theory can be revised so that we can cut down on those low probabilities, right? Mm-hmm. And so I think that's more what and maybe Mike would say, no, we know enough now that Darwinism is not that good overall. Okay, but I think one could make the case is, I'm agreeing, it's way low probability you're going to get the propulsion system, the bacteria, out of this thing, right? But it's that particular low probability is going to piggyback on all these other very good explanations we can give with this theory, such that we're not going to chuck the whole thing, right, for this one bad case. And like every scientific theory has this problem, right?
So Jim, would you say that that's it? Like, again, evolution accordion term, right? Would you say, well, evolution in the widest sense seems to explain a great amount of data, and so that should consider us to, give I guess more credence to the mechanism in particular? Is that what you're saying, or do you think?
I mean, I think it's kind of just so every theory on the edges is going to have empirical problems, right? It's going to run into like really recalcitrant cases and data that it's going to have a hard time dealing with, right? And the degree that we're going to accept the kind of like admittedly ad hoc, low probability explanations that we have to make in those tough cases will be determined by how good the theory is overall, right? Mm-hmm. So I agree with you. Like, we could come up with some really bad ad hoc, sand fairy theory of how the winds could build the pyramids, right? And it would be just stupid because it's not embedded in overall well-confirmed theory, right? Mm-hmm. Now, and maybe, but and maybe there's something that both you guys would argue with is, well, if evolution by natural selection is an overall well-confirmed theory, that might be enough to like boost these otherwise low probability ad hoc explanations we have to give in these really tough cases, in the irreducible complexities.
Well, two things. Well, maybe one thing, the other one slipped my mind.
Sorry. I talked too much.
No. One is that you have to be careful in talking about evolution, as we all have admitted here, because it can mean different things in different usages. And in particular, there are two major things. One is common descent, that is, our organisms descended from each other. And the second is Darwin's theory that organisms can be built up by random changes and natural selection. The first one, there's lots of evidence for. The second one, there is Zippo evidence for, that Darwin theory can build complex systems. And as I think I said in the beginning of the program, that is what has 99.9% of the philosophical and theological and even scientific impact. It's not that, dogs are descended from wolves. What's more, when you think about common descent, I have argued that it's actually trivial. It's a trivial thing because it says that, you've got two organisms, they have some common feature, but they're different species or something. Mm-hmm. So back in the misty past, maybe if an ancestor had that feature and later different lines developed, well, then maybe, it would explain why these two have it. Okay, let's say that's true. But number one, it doesn't explain the feature. It posits it, that the ancestor has it. Yeah. And that by itself does not explain how you get the two new species. So pretty much it says, well, these guys are related, but we don't know why they are different organisms. We don't know where these features came from, and again, I think that's, it might be an interesting fact about natural history, but as far as anything deeper goes, it's pretty trivial.
So Mike, you would say the problem here isn't at the edges. I agree with you, Jim. We do have these problems at the edges of various scientific theories. But Mike, would you say the problem is dead in the center?
Yeah. The problem is Darwin's mechanism, mm-hmm. and that is the heart of evolution.
It's pretty center.
Lamarck and other folks proposed that organisms were related and changed and stuff over time, well before Darwin did. But it was always a sort of teleological or inbuilt or process. And Darwin's claim to fame was not that organisms descend, but that he said he had thought of an utterly unguided, unintelligent process, as unguided as which way the wind blows, that could account for eyes and giraffe necks and wings of eagles and so on. And that is exactly the part that has zero to very negative amounts of evidence for it.
Right. Mike, would you mind if we took a question or two that were sent in?
Yeah, that'd be great.
Great. Cool. And then Jim, if you had anything else you wanted to discuss,
sure.
Please bring it up too, because I know that this is relevant to some of the things you've been writing about related to mind, which is always fascinating. So here's a question, Mike. This is a common one. This is from Peyton. He says, how would you respond to the claim that ID can't be validated because cases that imply design can be matched by instances of what seem to be critical design flaws? Animals often seem poorly conceived. So the old argument from dysteleology, Mike, what's your response to this?
Well, dysteleology is a classic argument from ignorance. It essentially says, I don't know why that thing is there. Looks pretty silly to me. Therefore, nobody would have made it that way. So you don't have positive evidence that argues that nobody would do it this way. You're just making your own judgment. And those sorts of judgments have a very poor track record in biology. Just to take one, a lot of people did and still do point to the blind spot, the so-called blind spot in the eye, and say that it's evidence of bad design because they would have designed it differently. Yeah. And you say, well, okay, why don't you go ahead and build yourself an eyeball the other way and show us how much better it is. Mm-hmm. But a series of papers has shown that the backward or the wiring of the eye is in fact optimal, that there are cells in the retina that channel light directly from the retina down to directly from the surface of the retina down to the nerves of the optic nerve, and they don't come, and the blind spot doesn't interfere with those. Additionally, the arrangement makes it easier to supply the retina, which is a very has high metabolic needs because it's constantly being bombarded with light and so on. It makes it easier to supply those repairs and nutrients and so on.
Right.
So the point is that just because you think that you would have done something different is not an argument that it's bad. These are the eyeballs that eagles use to see prey from a mile or two away.
Right.
So this is more or less, well, it's an argument from ignorance.
Yeah. So that's, this one has always fascinated me for a couple of reasons. Is even if you think that something is poorly designed, and maybe it isn't, because just because you don't see the purpose doesn't mean that you see there is no purpose, right? There might just be design constraints that you don't realize, for example, right?
Exactly.
But even if you think something is poorly designed, and I'll give an example of something I think is poorly designed. My mom used to drive a Pontiac Aztec, and and I've always thought it was poorly designed, but at no point did I think that it didn't have a designer.
Exactly.
So it's just a bad one, right? So it's kind of a cheeky response, but like design is design, whether it's good or bad, right? Now, the other thing that strikes me about this argument is it really just seems to be a species of the problem of evil generally, right? Because the question is like, why would God let bad things happen? And this is just a particular species of that. That's really what it comes down to. And then my response to that is, if you're going to ask a theological question, you better be willing to accept the theological response. But now we're just beyond doing science anymore.
Change the game.
Right.
The game's
There was a member of the National Academy of Sciences, a guy named John Avise, who was an evolutionary biologist. He wrote an entire book about why the genome is not intelligently designed. And almost all of his arguments were of this type, that if you break a certain gene, then you smell bad because it allows this ammonium containing compound to escape from your skin and so on. Mm-hmm. And he had a chapter devoted to my stuff in Darwin's Black Box, and he did nothing more than kind of wave his hands at that. So a lot of people get confused that, number one, things might be more complicated than you can tell, and perhaps what you think is not the right design is in fact better. Number two, that life has a history and that accidents and damage can happen over the long term. And so you would not expect everything to necessarily be in pristine shape. Just like the Aztec, it probably had a few scraps or scratches and bumps on it. And it says nothing. It still says nothing about how an unintelligent mechanism could build these things. Right.
Jim, do you have anything else that you wanted to put out there from kind of the way that you've thought about this?
Yeah. So Kant distinguishes between ordinary sense perception and aesthetic perception, the perception of beauty, by he thinks when you perceive something beautiful, it has a purposiveness without a purpose, that you look at it and it seems to be some kind of unified whole, right? That somebody is trying to tell you something with, okay, or seems to be up to something, even though you can't necessarily articulate what it is, right? Or the ability to articulate what the purpose of it is independent from your perception of the purposiveness of it, right? And he thinks that's what's behind aesthetic judgments, that we find that kind of the coherence of what we're perceiving, like through our senses and emotions, is sort of cohering with reason, even though we can't really say how. Okay. And for Kant, the entire scientific endeavor presupposes the aesthetic judgment, right? Mm-hmm. Because what happens is you perceive a law, you perceive a unity, but then there's always this, well, it's got to fit into something broader, right? It's got to fit into some broader explanation, even though I don't know what it is. So he thinks it's an aesthetic kind of judgment, right? It's an emotional kind of judgment that keeps the scientific endeavor up and running. Okay. Now, Kant thinks an aesthetic judgment can never lead to a grounded scientific inference, but yet it keeps us motivated to look for stuff. Okay. And at the end of the day, when pressed, Kant will say, yeah, if you were to say, and therefore the whole thing is designed by a benevolent creator, he says that is not crazy. He thinks that would rightly satisfy like the eyes of faith. But he also thinks if someone says, well, wait, no, it's just because we're committed to an open-ended scientific process, right, that we keep doing it, and I'm not going to make that inference. He also thinks that's not crazy either, right? And so I think this is end of the day, like kind of where I am on the ID thing, and Pat will see this. A similar view I have in other regions too, right, is that you could look at this thing.
I'm still convinced Jim's a Humean. He just
I'm showing a different card. It's a Kantian card, right? Actually, is that you could look at this evidence. I think, yeah, if you made the inference that, yeah, ergo, this confirms some things I'm committed to, right? And the fact that the very scientific process presupposes this kind of commitment to there being somebody trying to tell me something by the universe is not an insignificant datum, though I don't think it proves anything, right? Do you see my point, right? And so I think I would look at someone like yourself and say, yeah, I don't think that you're off anywhere, right, in what you're doing, right? And I might even follow you there, right? But I also think that it is a leap, maybe in principle too big a leap to say from any kind of like something like natural science that is open-ended, that there can be further discovery that would overturn things. To say that someone refusing to make that same inference that you and I might make is somehow an error, I think that's too far. Yeah.
Okay, well, that's
a lot, by the way.
Fine, but that's fine. But I just refer back to my talking about the Big Bang theory, that somebody could always say, well, science might in the future have a better explanation which preserves the static, eternal nature of the universe. Yeah. But right now, which is what science can deal with right now, the positive evidence looks very much like it supports design. We know of no other process which could explain this, Darwin's theory notwithstanding. And so to withhold one's judgment in the hope of, I don't know what else would be a better explanation.
Like Thomas Nagel recently said, I thought this is brilliant, that you can't like appeal to a possible future scientific revolution is not an explanation, right? Okay.
Yeah.
I agree, right? But also I think if indeed, and this is an interesting question, if indeed what the ID asks us to do is to make an inference that is just inconsistent, and not my view, but the view that people say is by bringing an interventionist teleological explanation into the picture, it's just contrary to the scientific method, right? That's not an explanation either. Do you see what I mean? And that's why for me, I'm kind of open to an agnosticism about the status of these arguments, right? But I actually think that agnosticism is enough to confirm a prior commitment to something like religious belief, right?
Yeah. So two things here, just real quick to help frame it. And this was the actual kind of way I framed the topic of this conversation is ID scientific? Now, the first thing that always concerned me, because what is scientific is, of course, a wonderful philosophical debate, right?
Yeah.
Is not whether it's scientific, but is it true, right? And I started off kind of just, I guess, a friendly agnostic, right? Like I was, didn't really, or probably even worse than that, because for whatever reason, and Jim, you'll know this, Mike, I'm sure you're familiar, since I was very much influenced by Thomism, I would say kind of, I don't know, maybe the general direction of the Thomists that influenced me tend to not be very friendly to ID, right? So
they're pretty frosty about it.
Right. So that actually kind of caused me to look away for a while.
Yeah.
But there were enough really smart Thomists who said, nah, like Rob Coons, for example, he's quite friendly to ID. That made me want to, and then I became like a friendly agnostic. Then I read Behe's books, loved them, and now I'm like, no, I think this is right? I actually do. Now, if you read Michael Behe's Wikipedia page, it's like 27. It's like a 27-page hit piece on the guy. It's terrible.
Yeah.
But yeah. So two things here. One is that yes, is this science? Should this be science? Is it a science stopper? But then also we could flip it, right, and ask, what might we be missing if we don't permit this as a valid science? Like, are we going to hurt ourselves in other ways if we don't at least have as an option on the explanatory table intelligent design? So however you want to respond to what Jim said and I said, Mike, take it away.
Oh, let's see. My capacity for remembering short time.
Sorry.
Thank you for your patience, Mike. Yeah.
But let me just, for listeners who haven't heard before, why do I think ID is scientific? Because lots of people don't. Lots of scientists don't. It is scientific because it's based on detailed empirical observations. The molecular machinery of the cell, how cells and biological systems operate. This was all hard won by lots of experiments and so on. And number two, it uses normal modes of reasoning. Whenever we see parts that appear to have been put together for a purpose, like a mousetrap or such things, we always conclude that they required design because we can perceive purpose. That's not going to happen by chance. It's going to, it serves a purpose. And we know that minds have purposes and nothing else does. So I think it's scientific for those reasons. Empirical evidence is its basis and ordinary reasoning, just like every other scientific conclusion. Number two, what would we miss anything? Yeah, we would miss a lot. If you think that evolution explains the fantastic molecular machinery of a cell and so on, then pretty much there's no problem that evolution couldn't get around. So if you were trying to design antibiotics, say, you might say that, well, this can't last. We can't design anything that will last forever. Evolution will always get around our antibiotics. And you might aim for short-term fixes here, try to tamp down fires over there, but you wouldn't necessarily try to design an antibiotic that nothing could get around, that no living organism could get around. You might see the cell as weird, doing weird things that, you'd say, oh, that's evolution, and it turns out later on that in fact, it's doing really profound things. Now, you don't have to be an ID guy to do that, but you don't have to be an admitted ID guy, but you do have to be an effective ID guy. You have to assume that everything's intelligently designed, but you'll call it evolution. So when you find systems biology, when you find deeper and deeper levels of regulatory networks and so on, you wouldn't have predicted those from evolution, from Darwinian evolution. But if you were an ID guy, you might be more ready to test the depths of life. And just one more point is that, yeah, it never ceases to annoy me that Thomists are, as you say, frosty towards intelligent design. As a rule, there have been a number of great exceptions. And I haven't the foggiest idea why not, or why they are standoffish. It's true, as they have pointed out, that the scientific argument can't get you to God, let alone the God of Christian theology, but it gets you up a step. And if you look around at the society in which we live, we could use that. The folks in general are not debating whether, say, Thomas or or Duns Scotus had the better of an argument. They are debating, whether Richard Dawkins proved that that atheism is true. And why look at all the things that evolution can do. That's where the real action is. Mm-hmm. I would love it if the majority of people were, took it for granted that, gravity and natural laws show that there has to be an intelligence behind the world, and we're debating about higher level questions. But in our society, they aren't. And one of the first arguments that you get from a Thomist when talking about intelligent design is that, even if Darwin's theory is exactly true, that doesn't matter because we know that, shooting an arrow requires an agent. And only later on, as in Jim's paper that he hasn't read for 10 years. Only later on do they say, by Darwin's theory, we don't mean one that claims that there's no God or that there's no purpose or anything. We just mean, a philosophically naive theory. Mm-hmm. But nobody in the general public takes Darwin's theory to be philosophically naive, or very few people. They all think, and the press is happy to tell them, and the leading lights of biology like Dawkins are happy to tell them too, that Darwin's theory means there is no direction, no intelligence whatsoever needed. Right. Here ID is just saying, at least from our limited little sphere in biochemistry or cell biology, that's not true. Then I don't see why that offends Thomistic sensibilities. Yeah. And if you look at the reaction, the folks who say that, Thomas's fifth proof, just is confined to say natural laws, none of the atheistic scientists cares about that. Frankly, I mean, it's their mistake, but they don't. Right. But when I say, modestly, I say, I think common descent is true. I think, there's mutation. I think natural selection certainly works. But you know what? I think in many cases that it didn't happen by chance, but needed guidance or direction or programming or something. I've had the National Academy of Sciences condemn me by name. I've had, the Council of Europe condemned intelligent design.
Alex Rosenberg lumped you in with, what was it, Stalin in one of his papers?
Yeah, yeah, that was great. I love that.
That was nice. That was real nice of him. Yeah. Uh-huh.
Yeah. So it gets a big howl, and I think the point I'm making is that with all its limitations, it'd be nicer if Thomists would nonetheless, you can make your your caveats later, but they always lead with the things that they don't like about ID.
I agree. It has actually come to annoy me quite a bit as well, because one, I think they're comparing apples to orangutans, right? It's like, like you have said, first, one thing, let me just get off a couple of my annoyances. One is that Thomists themselves become really annoyed if you don't make the right distinctions between different schools of Thomism. Right? Like, God, yeah. Right? Yet they never make the different distinctions between all the people in ID, right? Who say many different things, right? Yeah. So they're like these easy sort of hand-waving dismissals that they themselves get very annoyed about, rightfully so, they commit when it comes to ID. So like, yes, okay, if somebody in ID is an idealist or they hold to a mechanistic philosophy of nature, then the Thomists can rightfully object and give their arguments against that. But you can't dismiss Behe because he says, and has said on this podcast many times, you don't hold to any, at least not, you don't advocate any particular philosophy of nature. You're making an empirical argument against a scientific theory. So one is I just think an intellectual laziness and a sort of easy dismissal attitude that is, I think, unbecoming of anybody who wants to claim to be a Thomist or just a philosopher in general. The other thing I'll say is like, yeah, where is the incompatibility here, right? Is the Thomistic project, we're doing metaphysics, any finite thing exists only insofar as God imparts essay to a restricted essence. Great, right? Right. And it can still be the case that natural selection or random mutation cannot build irreducibly complex systems, right? Like I've yet to find a really good Thomist critique either of a strict incompatibility of these lines, and specifically your line of thought. That's why I always say it's Behe's books that I'm talking, because there presumably there are people in ID that I would disagree with on things, right? And I'm sure you would as well. But I have not yet found what that incompatibility is, and I've really not found any Thomists, even Thomistic scientists, who've given. And I look to them specifically because I think, like, all right, if anybody's going to have a good reputation, it should be somebody like this, the ID, to give empirical counter arguments to your claims. And I just haven't found anything on that front. Sorry, I had to get that off.
Yeah.
No, I think Thomists are subject to the same, cultural, professional pressures of anybody else working in the American university, right? I think that's, I think, and until they reach a certain level of prominence, all that, they're going to feel like they got a lead punch with that. Well, I'm not one of those guys, just so you know. I'm a theist, but I'm not one of those, right?
And this is the sort of armchair sociology and psychology. But I've asked this to Mike before. I'll ask it. No, I agree with you, Jim, because how much of this is just wanting to have a seat at the secular lunch table, right? How much of this is just not wanting to have a Wikipedia page that looks like Michael Behe's, right?
I'm in a professional situation where I'm more likely to get in trouble for disagreeing with Michael Behe than I am with agreeing with him, right?
Is that right?
Yeah. So, not seriously, but if I were to get pushback from colleagues, it would be for what my disagreements with you. Yeah.
Okay. Good.
Yeah.
Well, I was at a meeting of the Fellowship of Catholic Scholars a couple years ago, and that was a point of disagreement. There were a lot of Thomists there who I gave a talk, and they were in line to ask questions afterwards, and antagonistic ones. But the thing that impressed me was a guy came up to me in the bar earlier and sat down. He says, I teach at a Catholic college, but if I taught ID, I would be fired. And it was clear that they didn't know what ID was, or they got their notion of ID from reading the New York Times stories about it or something.
Yeah.
Right.
I agree. That's human nature and life and stuff, but still can be annoying.
Yeah, I was telling Jim before too, is that that I'm sure it'll happen here after this, goes up on the podcast. Is there's most of my audience is super cool, even if they disagree. We have a lot of good, even Jim and I, we have good clash a lot of times on ideas because we're adults, right? We can do that. But whenever I have an ID guy on, I don't know where these people come from, right? You guys just attract a certain vitriol that I've never seen in any other type of conversation. So I don't know what that means. But it is a very unique thing. But my point is this, is that like you, Mike, I feel like I was misled on things that were not based in good evidence about ID. Like you, I had especially since I had a particular religious commitments for a large part of my life, evolution, fine, right? No issue. And not only just misled on that, but also misled about what ID was too. Cause I read the pop level articles and I heard from certain people that this was just pseudoscience or creationism in a tuxedo, a cheap tuxedo. It's never an expensive tuxedo. It's always a cheap tuxedo. Right. And so okay, smart guys are saying this and that frustrated me. So if nothing else, right, maybe I'm wrong. Maybe I'm completely wrong on this. Maybe we're all wrong. If nothing else, I just feel like we could at least try and give it a fair hearing here on the Pat Flynn Show, right?
Yeah.
Nothing else. I could at least do that.
Take it. Yeah, that's great.
So, Jim, did you have any final thoughts here? Mike, you've been super generous with our time, but I want to get you guys concluding remarks on anything.
If I just one last question, Mike. So if you, finally got your chairmanship at the National Academy of Sciences, right? And you're running it now. What does the professional biology look like? If you got if you had the ultimate kind of, within the academic culture, not necessarily the broader American culture, but within the academic culture, if you got the effect you wanted, what would the discipline of biology look like at the university level?
Gee, it pretty much looked like it does now, where 90%, 95% of people just work on how things work today. What's going on in the cell. One of the differences would be that you wouldn't see gratuitous attributions of things to evolution, which occurs in journals and textbooks and all sorts of things. They'll say things like, isn't it wonderful that bacteria have evolved a flagellum to help them move. It's mostly just a prior assumption that materialism, Darwinism, etc., has to be all the way down that I would change. Even evolutionary biology, almost all of it is either on trivia or very small things. I know somebody who works on the evolution of birds, and she looks at Carolina finches versus Carolina chickadees versus black-capped chickadees. And if you looked at them, you wouldn't see any difference whatsoever. And yet they are supposed to have separated from each other 4 million years ago. And you say, I would have expected more, but, okay, yeah, you can study questions like that. What distinguishes them? How did they change? But that is decidedly what they call microevolution. And folks who talk about macroevolution pretty much only compare DNA sequences, and they don't try to explain how things actually arose. So nobody in evolutionary biology is doing anything I think is, off base. It's just that they all are pointed in the one direction. They're just assuming that random processes are responsible for all of life. They don't try to prove that. They assume that. And I just want to make them aware that they are begging the question royally, and hopefully have some folks turn to that and see what that portends for biological research.
Very cool.
Excellent. Thank you.
Yeah. So let me say this. These conversations, we can only scratch the surface. If you really guys want the full account, then you have to get Dr. Behe's books. So, Mike, before we say goodbye, please recommend some of your works. I know you have two fairly recent books out. So if you could give us a brief idea of what those are and the best places to get them, that would be super appreciated.
Okay. The most recent book they all can be ordered on Amazon. Amazon.com. Most recent book is called A Mousetrap for Darwin. It's a different kind. It is a collection of all my responses to criticisms going back 25 years to even before Darwin's Black Box was published up till now. And I urge people to get that just to judge the weight of the objections to ID and compared to my responses. Mm-hmm. Before that, in 2019, I mentioned is a book called Darwin Devolves, and I urge people to get that too, because I think it's the final nail in Darwin's coffin, because it shows that his mechanism does, make small changes which can help species a little bit in certain environments. But overwhelmingly, those adaptive beneficial mutations are ones that break genes or degrade them. The first book is called Darwin's Black Box, and that just kind of takes a tour of the biochemistry of the cell. It's only gotten more complex since the 1996 when it was published. And most people think of the cell as some squishy little thing. They don't think about it much in terms of evolution. And it shows that, on the inside of the smallest layer, just like with, say, computers, they might look complicated on the outside with a keyboard and stuff. But if you look inside, they're even more complicated. That's what biology has turned out to be. And the other book was published about 11 years after Darwin's Black Box, called The Edge of Evolution. And it looks to see what our best examples of evolution in nature show us. And I talk about malaria, which is widespread and which has a lot of cases every year, and show that the malarial parasite, which is a little single-celled organism, took a very, very long time to develop immunity to chloroquine, because it needed not one, it needed 2 coordinated mutations to occur before it had resistance to the drug chloroquine. And yet, if it takes such enormous population numbers and time and generations to get 2 crummy changes in a pre-existent protein, I argued that Darwin's mechanism, even if there weren't these other problems, couldn't account for the complexity we see.
Right. Excellent. So a cumulative case, as they often say. And again, I can't recommend the books enough. Again, no matter how you feel about this issue, it never hurts to just go read both sides and see where you think the evidence, see where you think the weight of the evidence is, as they say. Mm-hmm. So, Dr. Behe, thank you so much. This has been an absolute pleasure.
Yeah, absolutely. I always enjoy it. Jim, it's good to meet you. Pat, talk to you again sometime.
Thank you. It's been an honor, Mike. Appreciate it.
Okay.